So hi and welcome back. So we have reached the video lecture of the insertion sort algorithm part 3. So we are going to see the time and the space complexity analysis for this algorithm. So basically we are going to analyze the insertion sort algorithm that we have learned in the insertion sort algorithm part 1 and part 2. So you can see that you have a pseudocode in the right side. Okay, so what we are going to do is that we are going to just recap the algorithm that we have studied in the part 2, and if you want the detailed version of this insertion sort algorithm part 2, then you can refer that video. And okay, so the prerequisite for this video lecture is that you should have finished the part 1 and part 2 of this insertion sort algorithm, and another prerequisite is that you must have the understanding of the asymptotic theta notations like big O, theta and omega. Although we will be only using these two mainly, but if you know this, then it will be good to know. Okay, so we are going to discuss the time and the space complexity. So mainly the time and the space complexity means that how much the running time of this insertion sort algorithm is. That means given an input, say array of size n, which is input in this case, so how much time it will take to say the sort the array. Okay, and how much space in the memory it will take to sort the array. So that thing is called the time and the space complexity. So we are going to do the analysis for this. Okay, before that, just quickly we are going to recap it. Okay, so let's recap the algorithm that we have studied. Okay, so just recap the algorithm. So say we have an array, some random array like say 10, 6, 2, 9 and 5. Okay, so if you see here, then it's not sorted. So our goal is to sort this array in ascending order. Okay, so what the main concept is that we will be having two variables I and j. With the help of j, I will be fixing my size of the subarray. Like if the value of j is 1, then the j will be somewhere here. That means the size of the array is 2. That means we have to sort this subarray first. Okay, and again when the value of j will become 2, then that means that now the j will be here and we have to sort this array. Okay, so the insertion sort algorithm goes like this, that you have an array of size n. Then to sort that array of size n, it will divide the array in this subarray of size 1, of size 2, of size 3 and up to size n, and it will sort each subarray. Okay, the property of each subarray will be like that. Suppose you have subarray for this array of size k, then the k minus 1 elements of that subarray will be already sorted, but the last element but due to the last element, the whole subarray will be unsorted. So your task is to just put the last element of the subarray at the appropriate position in the subarray so that the whole subarray becomes sorted. Okay, so let's go on to the example part fast to recap it. Okay, so see here we have two variables key and I, and we are going to iterate with the help of j from 1 to n, because the size of array 1 is already sorted. Okay, so that's why we are starting from the size 2, right? So initially j is pointing here, and if you see the key is a of j, that means we have to sort this array first. Okay, so this will be key, so key is equals to a of j, that means it's 6. Okay, now I is j minus 1, that means I will be somewhere here and j is here, right? So now you check this, both the conditions, these both conditions is being satisfied here. That means if you do note here that the n minus 1 elements means k minus 1 elements, which is singleton in this case, is already sorted, but due to this case the whole subarray is not sorted in the ascending order, so we have to sort it in ascending order. And the concept is that you pick up the last element and shift the all elements which are greater than the key or the last element of that subarray to the right by one step. Okay, so if you do this, then see that is the step for shifting the elements. So if you do a of I plus 1 equals to a of I, then you will get this array, right? And after that the I will come here. So value of I will become minus 1, and again when the while loop come here, then the this condition will not be satisfied, hence it will come out of the loop. And once it will come out of the loop, then as I have told earlier also, that once you come out of the loop, then you have the exact position that where the key should be, so that the sub array that I have become shorted, and that position is nothing but it's I plus 1, right? So if you see, if you do this step, then you will get like this, 6 and 10. So if you see, this sub array has been sorted. So now my main array will be updated here. Okay, now the j value will be incremented from 1 to 2. That means j will come here, which means we have to sort the array of size 3 now. If you do note, then again the k minus 1 elements are already sorted in ascending order, but due to this too, the whole sub array has been unsorted, hence our task is to sort this sub array. So if you go on doing this, then you will get the following steps, intermediate steps. Okay, then 6, 6, 10, right? Then 2, 6, 10 finally. Okay, so this sub array has been sorted, and finally your new array will be like this, 2, 6 and 10. Okay, so as you can see, this has been this is the process of the insertion sort algorithm. Now let's go on to the running time and the space complexity analysis for this. Okay, so if you see here, we so how many times this function will be called in order to sort the array? Only one time. Okay, that means once you call the insertion sort algorithm for the array A, then after the execution of this function, you will get the sorted array, right? So let's see the running time. Okay, so let's understand that let's see that this is line 1, this is line 2, this is line 3, 4, 5, 6 up to okay, so we are going to see the running time of each line, and then we'll add all the running times of all the lines, and finally we'll get the time complexity of that. So first we are going to do two cases. So first case is worst case. So worst case scenario. So worst case scenario will occur when your array is sorted in descending order. That means if this is your array, okay, then this is the worst case scenario. Okay, so now let's see the running time of this algorithm in the worst case scenario. So if you see here, as this function is called only one time, and hence this statement will run only one time. That means let's say the running time of this statement, first statement is C0, then the and as it will run only one time, hence the running time will be C0 into 1. 1 is for, that means it will be run one time. C0 is the running time of that statement. That means to run this statement, it will take C0 time, and since we are running this statement only one time, that's why it is C0 into 1. Similarly, if you see the total running time for this will be something C1 into 1, because C1 is the running time or the execution time, and the 1 is the number of times it is executed. So total running time will be C1 into 1. Now if you see here, so remember that we are using the zero based indexing. Okay, so if you see here, then the value of j is going from how much to how much? 1 to n minus 1. Okay, intuitively you will say that this statement will run only n minus 1 times, but no, because once your j value will become n, say n minus 1, so this condition will be satisfied. Okay, it will come inside the for loop, it will execute all the things, and it will go again after incrementing the value. Then after implementing, the value of j will become n, right? So when the value of j will become n, then again it will check this condition one more time. That means if this condition is satisfied, then only it will exit the for loop, right? So that means we are also checking the condition j is less than n or not for nth time also, right? So basically so the j is going from 1 to n minus 1, it's true, but we are checking this condition how many times? When the value of j is 1 to value of j equals to 1 n, right? So the total number of executions that this statement will be executed is n times. Understood? Yeah. So let's say the execution time for this statement is c2, then c2 into total number of times it will be executed, so c2 into n, right? Okay, now let's move forward. Okay, it's going to be tougher. Okay, so now let's see. So when the for loop will be executed, that means when you will come inside the for loop, you will come inside the for loop only then when this condition is satisfied. So this condition is satisfied for the values from where to where? J equals to 1 to j equals to n minus 1, right? So that means total number of time it will be executed is n minus 1, right? Understood? So let's say the execution time for this statement is c3 and total number of times it will be executed is c3 into n minus 1. Okay, so do note that all the statement inside the for loop will be executed n minus 1 times, but this statement, there is a declaration of the for loop, will be executed n times. Why? Because when the value of j become n, then it will check the condition at that point also. That means j is less than n will be checked for n times. Okay, so that's the case. If you come here for the statement number 5, you will find that the its running time will again be same, which is n minus 1, right? Now come here. So if you see here, we are going to see that this declaration of the while loop, how many times it is going to be executed. Okay, so let's say the execution time for this is c5, and now we have to find that how many times this will be executed. Okay, so do note here that when the value of j is 1, okay, when the value of j is 1, the value of I is what? 0. Okay, so how many times these two conditions will be checked? Now again, see here that as we are considering the worst case scenario, that means your array is already sorted in descending order, but our main aim is to sort that in ascending order. So if your array is sorted in descending order, then that will be the your worst case scenario. Okay, so in the worst case scenario, if you see, then this condition will always be true. Okay, fine. Do note that this condition in the worst case scenario will always be true. That means now you have to depend on this condition. If this condition is true, then you are going to enter inside the while loop, and if this condition is false, then you are going to exit from the while loop. Okay, now let's see that how many times this statement will be executed, right? So when the value of j is 1, because it's starting from 1 here, then the I value is j minus 1. So for while loop, the starting value of I is from j minus 1, which is 0 in this case. Now let's see, when the I value is 0, it will check this condition, right? It will find that it's true. That means it will be executed c5 times, means c5 one time, it will be executed one time, and hence the execution time as of now is c5. Now this condition is satisfied for I equals to 0. Now it will come inside the while loop, do some operation here, and it will decrement the value of I to I minus minus. Now the I value has become minus 1. So it will again come here, it will again check this condition, that whether this condition is satisfied or not. That means this statement has been executed one more time. That means I am going to write C5 one more time, right? And this condition is false now, so it will come out of the while loop. That means this statement will not be executed more. So how many times? So what is the total running time when the value of I equals to 0? So when I equals to 0, the running time of this statement is 2 into C5. If you go on doing this, when j equals to 2, then I equals to 1, then you will find that the total execution time for this will be 3 into C5. When j equals to 3, I equals to 2, then it will run 4 into say C5. Okay, correct? Fine. Yeah. So write it once more here. So say when j is equals to 1, I is 0 here, right? That means how many times it will be executed? 2 times. So the time is 2 into C5. When j equals to 2, I equals to 1. So how many times it will be executed? 3 times. 3 into C5. When j equals to 3, I equals to 2, how many times it will be executed? It will be executed 4 times, right? Okay. So similarly, when j equals to n minus 1, then I equals to n minus 2, how many times it will be executed? N into C5. So I equals to n minus 2, it will be n, not n minus 1 into C5, right? So you just add all these, then you will get the running time for this. So that's what we are going to do here. Okay, so let's add here 2 plus 3 plus 4 in order to n. Now just add 1 and subtract 1, 1 minus 1, right? And if you do this, then you will get something like this. Okay, so let's write here what is the running time. N plus 1 by 2 minus 1. Okay, now let's see the running time for this. Okay, so running time for this statement, say again, so when the value of j is equals to 1, when the value of j is equals to 1, I is 0. Okay, so when I is 0, how many times will this statement will be executed? So see, when I equals to 0, then this condition is satisfied. That means both these conditions are satisfied for the worst case scenario, right? So it will come inside the while loop. It will be executed 1 time. So say if the running time is C6, then it will be executed 1 time, that means C6, plus when the I value will become minus, it will go again, it will check the condition, then it will be false, then it will come out of the loop. That means this statement, when I is negative, it will not be executed. That means when I is 0, only 1 time this statement will be executed. Similarly, when I is equals to 1, how many times it will be executed? So 2 into C6. For I equals to 1, it will be executed. For I equals to 0, it will be executed. But when the I becomes negative, then it will not be executed. That means total 2 times it will be executed, right? Now say similarly, when I equals to 2, it will be executed 3 into C6. Similarly, as we know that the value of I will go from 0 to n minus 2. So hence, when value of I is n minus 2, then it will run n minus 1 into C6. So what is the running time for this? The running time will be is to just add all these cases. Okay, so 3 into C6 plus dot n minus 1 into C6, right? So you just take common here, you will get 1 plus 2 plus 3 dot n minus 1. Okay, if you do here, then you are going to get n into n minus let's say, so n minus 1, yeah. So n into n minus 1 by 2. That's the running time for that statement, right? Okay, so we got the running time for that statement. So let's write here. So the running time is n into n minus 1 by 2. And same running time for this will also be the same here. So let's say C7 into n minus 1 by 2. Now if you don't note here the running time for this, as this is now outside the while loop and inside the for loop, so hence the running time for this will be same as this. So C8 into n minus 1. Okay. Now let's calculate the total running time for this. So the total running time, okay, and do note we are calculating for the worst case scenario, will be to add all these times. So C0 into 1 plus C1 into 1 plus C2 into n minus 1 plus C2 into n, C3 into n minus 1 plus C4 into n minus 1 plus C5 into n plus 1 by 2 minus 1. Okay, C6 into n minus 1 by 2 plus C7 into n minus 1 by 2 plus C8 into n minus 1. So you add all these with the total running time. Now if you add all the n square terms, n terms and the constant, then you will get the expression of the Tn like this. So you will be getting say C1 prime into n square plus c2 prime into n plus c3 prime and c3 prime. Okay, so this is, so if we don't note here, then we can write this running time for the worst case scenario as big O of n square. Okay, so this is the running time of the worst case scenario. Okay, so I hope you have understood the worst case scenario. Now if we are going to see the best case scenario, okay, just note it if you want, or otherwise I can erase it. Okay, okay, fine. Yeah, so now let's see that what is the worst case running time of this algorithm, best case. So we got that worst case is equals to Tn is equals to big O of n square. Now let's say second, the best case. Okay, so in the case of best case, now let's see that what will be the changing. Okay, so best case means your array is already sorted in ascending order, like 2, 4, 6 and 8. Okay, so this is the best case for this insertion sort algorithm. So in the case of best case, if you see, then the for these two statements will be executed as usual. This for loop will also be executed as usual. Now if you see this while loop here, it will be changed here only. Okay, so let's just see, we are going to write the new running time for this. Okay, so when j equals to 1, I value is equals to 0, right? When j equals to 1, I is 0. So for the best case scenario, this condition will always be false, right? This condition will always be false. That means inside this while loop, these will not be executed anytime. So the execution time for this both will be 0 and 0. Okay, now we have to find just the execution time for this declaration of the while loop. So if you don't note here that how many times these two conditions will be checked. Okay, so when j equals to I 1, then I is 0. So how many times it will be executed? Only one time. Why? Because whatever the value of I is, this condition is always false. So for each iteration of j, this while loop will be executed only one times. That means for j equals to 1, okay, and if the execution time for this is c5, then it will run only one time, that is c5 into 1. For j equals to 2 also, it will run c5 into 1. For j equals to 3 also, it will run c5 into 1. For j equals to n minus 1 also, it will run c5 into 1. So if you add all this, you will get the total running time for this while loop declaration part is c5 into n minus 1. Okay, so c5 into n minus 1 is the case. Why? Because this condition is always false, right? So whatever the value of I is, let's say when j equals to 2, I is equals to 1. So for I equals to 1, this condition is false. So it will come out of the while loop. That means it has executed only one time. Okay, so for each value of j, or whatever the value of I is, it will run it will run only one time. Okay, so from here onwards, we can see that the best case running time for this will be how much? So Tn, best case will be c0 into 1 plus c1 into 1 plus c2 into n plus c3 into n minus 1 plus c4 into n minus 1 plus c5 into n minus 1 plus 0 plus 0 plus c8 into n minus 1. So if you add all these, then you will get something c1 prime into n plus c2 prime. So this is the expression for the. Okay, so if you write the notations, then you will get big O of n. So what is the big O of n here? Big O of n is the upper bound for the best case, and t of n, if you write t of n, then this is the upper bound for the worst case also, and the upper bound for this algorithm also, right? So you can say this is the upper bound for best case, right? And this is upper bound for worst case and algorithm also. Upper bound means the time complexity cannot be greater than this. So either if you take the insertion sort algorithm as a whole, or you take just the worst case of that algorithm, then the upper bound will be n square only. So I hope you have noted this. Okay, now let's what are the different ways that you can say you can denote the running time for this insertion sort algorithm? First, we have seen that we can either denote the running time for 2. Okay, let's say t of n is big O of n square, and we can write this and we can explicitly mention that this is the upper bound for the worst case, and t of n equals to big O of n, we can see that this is the upper bound for the best case. Okay, or you can write that t of n is equals to big O of n square, this is the upper bound for the algorithm also. Okay, and otherwise you can write the running time as, okay, what say the theta of n, which is the lower bound, and t of n is equals to big O of n square. Okay, so it will not be theta of n, and there's a theta of n square, right? So this is how you can denote the running time of this insertion sort algorithm. So this video has been already very long, so we are going to discuss the space complexity and analysis in the next part of this video. So I hope you have understood this insertion sort algorithm part 3, the time running time complexity. So that's it for this video. Thank you and Jai Hind.